Right, this first sequence looks pretty horrible. It's not a linear sequence. It's not going up by a constant amount. It's not a quadratic sequence. It doesn't seem so. I mean, that's not very nice for 2 marks, given that you've got all these fractions. And actually, what you have to do is kind of forget for a minute about the bottom numbers and just look at the top numbers, the numerators. And actually, 1, 4, 9, and 16, they're just your square numbers. So in fact, your nth term for this is n squared. When n is 1, you get 1. When n is 2, you get 4. When n is 3, you get 9, and so on. You have to recognize, in this case, that it's the square numbers. And then let's look at the bottom numbers. We've got 2, 3, 4, 5. These are going up by 1 every time, which gives you an nth term essentially of n. It's like your 1 times table. How do you, but it's not. We don't start with 1. So what do we start with? We start with 2. It's going to be n plus 1 is your nth term for this sequence here. And so finally, your nth term is n squared over n plus 1. Okay, now we've got a quadratic sequence. We're told this, and it's in the form an squared plus bn plus c. So what should we do? Let's find out the first difference. So that's plus 10, that's plus 16, that's plus 22, and then the second difference is plus 6 and plus 6. It's constant. That's what you get with a quadratic sequence. We're going to use this information because now we are going to write down the sequence in terms of a, b, and c. So when n is 1, I'm going to substitute that in, and I'm going to get a plus b plus c. When n is 2, I'm going to get 4a plus 2b plus c. And when n is 3, I'm going to get 9a plus 3b plus c. That's my sequence in terms of a, b, and c. I'm going to find my first difference. This one is 3a plus b. This one is 5a plus b. And that allows me to find my second difference, which is 2a. And now I can start comparing. So I've got my actual sequence, I've got the general sequence. It must be that 2a is equal to 6. And therefore a is equal to 3. Next bit, it must be that 3a plus b is equal to 10. But I know what a is, it's 9. So 9 plus b is equal to 10. And that will give me b is equal to 1. And finally, I've got that a plus b plus c is equal to 2. So I can substitute that in. 3 plus 1 plus c is equal to 2. So 4 plus c is equal to 2. C must equal minus 2. And I've worked it out. It would finally, I didn't need to write this down, but it would be 3n squared plus n minus 2. That is the nth term of this sequence.